Alright, welcome everyone to the next lecture in the Intro to Stats and Data Analytics course. I'm Makami here, and today we're going to be talking about the methods of collecting data. So to start off, we're going to be talking about descriptive statistics. Now, it's basically just how we describe data. So some terminology to start off with. A data set is just a collection of descriptions of different instances of the same phenomenon. So it's basically just a collection of data points effectively, things that we're trying to measure, different attributes of what we're trying to measure, and we've got different cases for them. Cases or observations make up the data set. So most of the time you see data, it will be presented to you in a tabulated format, and each of the rows represent a case or an observation, so it's effectively a data point. And the columns of the cases are the variables. So these are the attributes that you're trying to measure: gender, whether someone smokes, their income. These are variables. Variables can also be qualitative or quantitative. Qualitative variables are ones that can't be ordered in a logical or numerical way. Things like eye color, type of transport. These are qualitative variables. And quantitative variables are attributes that can be measured, where numerical operations make sense. Things like shoe size, weight. Those are types of variables that are quantitative. So here's a data set that you might see in practice. You've got a tabulated form here that records the year, the gender, and the GPA. Each of those rows that you see in the dataset above represents a case or an observation. For example, in the first row, we've got an observation that someone is a senior, they're male, and their average GPA is 3.13. The last row, we've got someone who's a freshman, they're female, and their average GPA is 3.86. Hopefully you see by now that each of the columns, year, gender, and GPA, are the variables of our data set. And just to follow on from that, the year, for example, is a qualitative variable because it's categorical. Someone is either a freshman, a sophomore, a junior, or a senior. They can't be more than one. Gender is also qualitative, but the GPA column is a quantitative variable because it is something that numerically we can perform operations on, and it kind of makes sense. Adding two GPAs together gives you a higher GPA. Okay, so this slide here is just going to be going into some of the more mathematical rigor behind what we just talked about earlier. It's a completely optional slide, so if you haven't learned some of this stuff before, or you're not comfortable with mathematical notation, you're more than welcome to skip it. I'm not going to be diving too much into a lot of rigor throughout this course, but I'll only dip my toes into it with you guys if I feel like it's important. So to make sense of this formal definition we have here for a statistical variable, we first need to define what all these variables and symbols mean. So the statistical variable is represented by the letter big X. So it's effectively one of the column values that we saw on the previous slide. The total sample space is given by the symbol omega, and it's the collection of all possible observations, cases. It's effectively all the possible rows you could have in a given situation, and that's often termed population, and we'll come back to what this term means in just a moment. The variable S represents the set for all the possible values that big X can take, so it's effectively all the possible values the statistical variable can take. And as a note, the set S is a subset of the total sample space omega. W represents the case or observation. It's effectively one of the rows that we saw in the dataset example above. And just to note that W, an observation, belongs in our total sample space omega. And little y is the final value that the statistical variable X can take on for every observation W that we see. And if S represents the set of all possible values that we can have for the statistical variable X, then Y must belong in the set S. So what this definition means is that the statistical variable X takes on some value Y for every case or observation that we have in our data set, and that is represented by the letter W, whereby the number of possible values is contained in the set S. So as an example, if big X represents gender, the possible Y values are contained in the set S. In this case, we've only got the choice between male and female. Therefore, that means each case W that we have, that is every row we have in our data set, will either have M or F for that column value. Okay, so we just went through an example of a data set that had rows and columns, observations, and variables. So let's go through a few examples together just to try to see whether or not you may understand the content thus far. So for the scenarios below, please describe what the cases are and what the variables they are measuring, and is the variable or variables quantitative or qualitative. So the first example, people in a city are asked if they support a new recycling law. The second example, we collect data from a sample of academics with the question that asks, do you consider yourself a good researcher? And the third scenario is we record whether or not the literacy rate is over 80% for each country in the world. So I want you guys to pause the video and just have a think about each of these cases. Pause the video, have a think through each of these scenarios, and have a think about what the cases would be and what the variables we are trying to measure in each of those cases would be. Okay, so for the first one, the cases would just be the people in the city that are asked this question. It may not be everyone, it's just the people that were asked. And the variable in this case is only one. It's their answer to whether or not they support the new recycling law. And it's a qualitative variable because they can either say yes, no, maybe, not sure. It depends on what the categories are. I haven't specified it here, but just keep in mind that this is a qualitative variable because they can only really give one answer and they can't have, say, both yes and no. For the second scenario, the cases are the academics that make up the sample. So the academics that were asked this question effectively. And the variable is similar to scenario one. It's their answer to whether or not they consider themselves good at research. And it's qualitative because they might have a selection of answers to pick from. Yes, no, maybe, kinda. It depends on how they structure the questionnaire. And for the third example, the cases in this case would be each country in the world because we're recording whether or not literacy is over 80% or not for each country in the world. So those would be our observations. And the variable in this case is the literacy rate, which would be a percentage. And because it's a numerical quantity, it's a quantitative variable. Okay, so I brought up the term population earlier in the flexing slide, but we really should revisit it because it's actually going to be something that we come to time and time again. So we're going to be introducing it here in a more precise definition. So a population represents all individuals or objects of interest. So it's effectively all the possible cases and scenarios that you could possibly have when you're doing data analysis or collecting data. A sample is a selection of cases, so it's always going to be a subset of the population. It can also include the entire population, but if your sample includes the entire population, it may as well be the population itself. So data is generally collected from a sample, and that's because in practice, it's generally highly improbable or highly unlikely that you'll be able to collect data from an entire population. So a toy example of this could be a survey given out to a class versus all the students at a school. Let's say the survey was trying to gauge the opinion of a particular teacher and there were 10,000 students at the school. It seems pretty impractical to send out a survey to 10,000 students when you could really easily just give the survey to one class and see what their opinion is and try to make some judgment on what the overall consensus of the teacher and their opinion of that teacher is based on that one class. Which brings us to our next point, and that's the process of using data from a sample to discern information about the population is called statistical inference. And from here on in, I'm just going to be referring to it as inference. So this is where you try to use the survey from the one class to try gauge what the whole school would feel like about a certain teacher or whatever it is the survey is asking. Okay, so let's go through another example now. So after a flight from Australia to New Zealand, you receive an email from the airline asking you to fill out a survey regarding your satisfaction with the travel experience. The airline then uses the data from all responses to the survey for analysis. So I'll be asking you, what is the sample and population that the airline is interested in? And the second question is, do you think the survey will give an accurate portrayal of true customer satisfaction? So once again, pause the video, have a think about this based on what we just described in the last slide, and unpause when you're ready to hear the answer. Okay, so let's have a look at the answers to these questions. Okay, so the answers to this, the sample would be the people who chose to fill out the survey, and the population would be everyone who flies with this airline. So your sample is what you're trying to use to gauge how everyone would feel about their travel experience with this airline. Okay, so for the second question about whether or not we think the survey will give an accurate portrayal of customer satisfaction for the entire population, the answer is actually no, it won't give an accurate portrayal. Because if you think about this intuitively, most people won't bother filling out surveys. I myself don't usually fill out most surveys after flying with an airline or dealing with a customer service rep. It's only when I feel like I've had a really good experience or a really bad encounter that's when I'll most likely give feedback. And that's true for most people. So surveys generally won't give an accurate portrayal because if only the people that had really good or really bad experiences reply, it's going to introduce really weird skews in your data. Okay, so based on the previous example, it kind of now begs the question of whether or not we can trust our sample data to make inferences, because if we can't trust our sample data, then there is no way we can make an inference about the population. Well, it really just comes down to how the data is collected, and that method for collecting data we will touch on more as the lecture progresses. But just know that surveys, voluntary polls, questionnaires, anything that you can kind of opt into voluntarily will always introduce something called sampling bias. And based on the example we gave earlier, I hope that makes a bit more sense now. So the way you can overcome sampling bias is to do something called random sampling. So with the airline satisfaction example we gave earlier, instead of sending out an email to fill out a survey regarding your customer satisfaction with the flight, you could collect the data by calling up a random sample of customers on that flight and asking them for their satisfaction feedback. And the reason this reduces sampling bias or almost effectively removes it is because every single customer now on that flight has an equal chance of being picked. And because of that, there's most likely not going to be much skew because you're not going to be always getting people who either have really negative or really bad experiences. You will most likely get a lot of people who had pretty neutral experiences. So that means random samples are a much better representation of the true population. And if you can do that, you should do that. So we're going to be touching a little bit more on the methods of collecting data. And like we saw earlier, it's an extremely important thing because depending on how we do it, we may or may not introduce bias in our data. The method of collecting data is also really powerful because it can reveal whether or not there's association or causation between variables. And we'll come back to the methods themselves later, but for now, we're going to be touching on association and causation. So two variables are associated if the values of one variable tend to be related to the values of another variable. And two variables are causally associated if changing the value of one variable influences the value of another variable. And you've probably seen this a lot reading other things, but association does not imply causation. Okay, so let's go through some examples now. For the sentences below, state whether the sentence is implying no association between the variables, association without implying causation, or causal association. And if there is a causation, indicate which variable is affecting the other. So the first example is putting a goldfish into a larger pond will cause it to grow. The second example is goldfish who live in larger ponds are usually larger than goldfish who live in smaller ponds. And the third example, pet goldfish sales are the same even with different levels of spending on advertising. So pause the video for a bit, have a think about it, and when you're ready to hear the answers, we'll keep going. Okay, so looking at the first example, the sentence, putting a goldfish in a larger pond will cause it to grow, that's an example of a causation because the size of the pond here implies it has an effect on the size of the goldfish. The second example is an association because it only says that larger goldfish tend to be in larger ponds. It doesn't say that larger ponds will cause the goldfish to be larger. And the third example actually implies no association because it says in the sentence that the goldfish sales didn't seem to vary at all when the advertising spending was changed. So now let's go back to the methods for collecting data that I skimmed over before we touched on association and causation. So it comes down to the question of how can we determine if the analysis shows an association or causation? Because it's all well and good to just pick apart random sentences, but when we're trying to make sense of data, how can we do this? It again comes back to how we collect our data. And depending on what we're controlling and what we're not controlling, it will determine the type of study or experiment. So just some extra terminology now. An observational study is one where we put no control on any variable. We just observe things as they are without interference. So a researcher might go out to the farms and note how much fertilizer different farmers use on their crops. We're not interfering with how much fertilizer they put on, we're just observing. That is an observational study. A statistical experiment, or just an experiment for short, is where there's active control of one or more variable. So it will be like us going out and observing those farmers, but we're now telling the farmers to use a specific amount of fertilizer and we vary that. That is a statistical experiment. And continuing on from the statistical experiment is the randomized experiment, where the value of the variables for each case or observation is determined randomly. So we'll touch a little bit more on this now because a randomized experiment is probably one of the most powerful ways you can collect data. Okay, so let's have a look at an example here. A university professor writes 2 final exams, Exam A and Exam B, for her class of 100 students, and would like to know if the 2 exams are similar in difficulty. There are 2 approaches she's deciding on how to determine this. The first approach is, on the exam day, she'll give the first 50 students who enter the room Exam A and the remaining 50 students Exam B. And the second approach is printing out all the student names on index cards, shuffling them, then dividing them into 2 equal groups of 50. One pile of names will get Exam A and the other pile will get Exam B. Now, she's hired you as an assistant and would like to know the following. What are the 2 variables we are measuring here? Which approach she should take? So once again, pause the video, have a think about it, and we will proceed. Okay, so in terms of what variables we are measuring here, hopefully you can see that the 2 variables are which exam the student will take, either Exam A or Exam B, and the other variable is the score that they receive on whichever exam they take. Now, which approach should she take? She should definitely choose the second approach because it resembles a randomized experiment. Because the second approach means that every student has an equal probability of getting Exam A or Exam B, because when the teacher prints out the students' names on index cards and shuffles them, the student's name could get put into the first pile or the second pile. There's an equal probability that they will end up with Exam A or Exam B, and that is a representation of a randomized experiment. Now, why is a randomized experiment good? Is because if a randomized experiment shows an association between 2 variables, it actually means we have grounds to establish a causation from one variable to the other. So in the exam example we gave earlier, if the professor had chosen to go with the randomized experiment approach, the second approach, and let's say when she was marking the exams, she found that the marks for Exam B were higher than Exam A, she can then conclude that Exam B is easier and that there's a causal association between which exam the student took and their final score. So that's why randomized experiments are one of the more powerful ways you can collect data and analyze it from there. And that's the end of this section. The next lecture will be a practical where we'll be diving into R and RStudio, and I'll be showing you some of the basics of the language, declaring variables, importing data sets, and all that fun stuff. And if you have any questions about any of the content we just discussed here, please feel free to leave me a comment and I'll get back to you as soon as I can. Thank you all so much, guys. See you next time.